trinomial, but there was no number here. So we're busy doing things like what's x squared plus 5x plus 6. Using that x marks the spot and saying, well, on the top, what multiplies to 1 times 6? What adds to 5? You can come up with two numbers, like 2 and 3. 2 times 3 is 6. And then 2 plus 3 was 5. And then you would know that this would be the factored version here. Right? Meaning if you multiply this back together, it would equal this. So we're just going to throw in, well, what if we have something other than a 1 in the front? Let me show you what doesn't work right away so you don't try to do the same thing you have been doing. If you've been doing what multiplies to this and adds to this, you'll notice that does not work. Because there's nothing that multiplies to 2 and adds to 7. We'll run into a problem right away. That's the first thing you don't want to do. Well, now we know, okay, multiply these two together, so that's 6. What multiplies to 6 and adds to 7? 6 and 1. Second thing you don't want to do. So over here, you just did this, right? You said, okay, I got a 2 there, I got a 3 here, and then I was done. But if you try that here, x plus 6, x plus 1, this does not multiply back to this. If you multiply this together, you get x squared plus 7x plus 6. It doesn't equal this. So you cannot just take these numbers and just drop them in here. Like so. So this is where you have to do the whole method and say, what multiply, well, come up with a box. Right, here's one method. And actually fill it in. The first term, put it in here. Last term, put it in here. And the two answers we get here will be the other two boxes. So 6 and 7, we already know the answers are 1 and 6, but don't go to the answer, these just go into the box. It's really 6x, and this is 1x. And to finish it up, do the GCF each row and each column. So we get a 3x this row, this 3 and x are in both of these. And then here, putting an x in both of these, and these two have to multiply equally in the sum. And you can work backwards to finish up the rest. 3x times what is 6x? 2. 2 times what is 1? 1. 1 times x is x. And you can see here are the two answers, the two binomials up here. So x plus 2 and 3x plus 1. So whereas before, when there's no number in the front, you can easily go from the x to the answer. But when we do have a number, you have to do this extra part. If you just try to skip it and say, oh, it's x plus 6, x plus 1, like over here, you'll miss it every time. You can see, here's the answer from the wrong way, x plus 6, x plus 1. It's nowhere close to the real answer. And sometimes you take shortcuts, you kind of get close to the answer, but it's just not quite. This way is not even close. You want to try to take a shorter route. There are ways of doing this without the box. Some people would say, well, I don't need to do the box. I just need to figure out that it's 3x squared plus 6x plus x plus 2. So they just go from here using the 7. Instead of having 7, use the 6 and 1. And then they just factor the first two back to the second two, which is the same thing as factoring this row, factoring this row. So no matter what method you pick, okay, the first two have a factor of 3x. And we end up with x plus 2. these second ones have a factor of 1, and end up with x plus 2. So there's your two x plus 2s. Everything is here. And left over is 3x plus 1. So you can see, doing the box, not doing the box, not a lot of difference as far as how much is writing together. More or less the same. So let's do a few more of these. Oh, by the way, if you look at the work here, they just give you one of the factors. So you have to find, let's see here. We have what, 3x plus 1 and x plus 2. Either of those over here somewhere. X plus 2, 3x plus 1. 3x plus 1 is 8. 3x plus 1. There you go. And then you can figure out how to fill out the bottom. And the other one is x plus 2. Okay, so that's going to be the first part. Oh, go through that. You want to do a few more? There? What do you think? Try number 2. We'll do it. By the way, the first thing you want to look for really when we're all done with this is there any number that goes into all these at the very beginning? Sometimes you can just take out a number at the beginning, but 2, 5, and 3 you can't. But if this is a 2, 4, and 6, you can take out a 2 and makes everything smaller. So, first step, attic basement. This is usually referred to as A, this is B, this is C. So on top is AC, the attic. 2x squared times 3, 6x squared. And then the basement, B, is just 5x. Notice, this time I'm putting the x's in. Okay. You can do that or not do that. It's up to you. What multiplies to 6x squared but adds to 5x? What do you say? Multiplies to 6x squared, adds to 5x. 3, 2, more 3x and 2x, right? 3x times 2x is 6x squared, and then 3x plus 2x is 5x. So the first is always the same. 2x, that goes in the middle. 2x squared. We got the 3. These are the two that gave you the 6x squared. And now we have the 3x and the 2x. Doesn't matter which way I put them. And there we can finish that. GCF is 2x squared and 2x. 2x. There's 2 in both of them, and there's an x in both of them. GCF is 3x and 3. 3. And you can work backwards to get to the other one. So right now we're at an answer of 2x plus 3. So 2x times what is 2x squared? And 3 times what is 3x? The same answer. 2x times x, 2x squared, 3x times x, 3x. And 3 times what is 3? 2x times what is 2x? Both of them, 1. There's your other final. several steps. Yes. 2 steps here. Multiply AC and then find these two. Go over here, set up the box. This diagonal comes from whatever these two turn out to be. And then do the GCF for each row and column. There you are. Done. I'll let you get started on that. Get the hang of it for a second. I'll walk around and see how you're doing. And I'll go over the back around 125 or so. Go ahead and flip it over now. Let's look at. All right. Here we are. Now you'll notice the answers on the back have a GCF out front. So that's the only thing different between the front and the back, is that these have a GCF of something. This is your first step. So what you're going to do is take what you've already been doing, add 1 step before all that. Add 1 step before that. So before you go ahead and put it in the box and use the X and all that stuff, the first thing you want to do is look at this and say, is there a number that goes into all of these? So in this case there is, which on this side there will be for all of them. But then after you do that step, it's going to do the same thing. So a lot of practice. And of course, if you can do it without the box or you have another method, there are lots of methods that work. I find that using the box usually is easier for most. Not all. So that's the first step. After this, everything's going to be the same. The fact that I took out a 3 means my final answer is going to be 3. And then the 2 parentheses. Whatever else I get. See here? And then you figure out just by using these numbers, okay, there's a 1. What multiplies to 6 adds to -5? -2 and -3. And you see there's no number here. So in this case, you don't have to use the box. Only we have to use the box if this is something other than 1. So we can go straight to the answer of x minus 2, x minus 3. So looking and noticing what's in front of the x squared really changes the length of the problem. Notice that this is the 1, these 2 numbers work right away. If not, then we have to go through and use the box. If you're not sure when to use, when not to, just use it all the time. You'd have something like this. X squared minus 2x minus 3x and then plus 6. And then if you did all the work, you'd end up with these 2. So it gets you the same place as one. Of course, go back here. It's like O is the answer. So common mistakes when you don't have the answers here, because chances are you're not going to have them for a quiz, is just forgetting to take this out. So you got to make this the first step. You can take out a question. Want to do another, or you think you guys have that? Pretty much the same. Notice here on number 2, I'll just mention this, I won't do the whole thing. But on number 2, the GCF is not a number. They don't, 1, 11, and 10, there's nothing that comes out, but they all have an X. See, normally there's no number, there's no variable here. Look at all the others. So that's the case. Your GCF here is just a 1 variable, X. And then all the numbers stay the same, they just drop by 1 variable. So you can can have DCF of a number, it could be a variable,